Homework videos for packet 4A, lesson 4. Problem number 5. Can a 3 foot by 9 foot rectangle be a scaled copy of 3 by 1 rectangle? Explain. So it looks like these two are different shapes. I mean, it's not the scaled different shapes and not the scaled copy. However, if you rotate the smaller one, now it looks like it. And when you compare the lengths, you always have to compare the corresponding size, which means that the longer side to longer side and the shorter side to shorter side. So if you compare shorter side, you get 3 to 1. And if you compare the longer one, you get 9 to 3. Do you use the same rule to get 3 to 1 and 9 to 3? Yes, it is, dividing by 3. So I actually answered this question. Sorry, I'm not supposed to. Let's move on. Problem number 6. You scale a square by the factor 2.5. The resulting square has a side length of 8 inches. What is the length of a side of the original square? So first of all, think about original one and compare the original one and the scaled one, which is new one. The new one will be bigger because you scaled by 2.5, which is bigger than 1. So now one side is 8 now. So what would the corresponding size of original one? So in other words, some number times 2.5 has to be 8. Problem number 7. One triangle had side 21, 15, and 18. Another triangle has 12, 14, 16. Are these triangles scaled copy? How can you tell? So again, you cannot, when you compare numbers of a triangle, rectangle, what have you, in geometry, you gotta compare the corresponding size, which means the small to small, medium to medium, and large to large. You cannot just simply compare the first number, second number, and third numbers because they are not corresponding. So be careful with that for problem number 7. Problem number 8. Carefully trace the triangles below. Cut out the traced triangles. Decide whether any two of the triangles are scaled copies of each other. Use any of the methods to discuss in class. So in class we had a conjecture that if two triangles have the corresponding congruent angles, in other words, if 3 angles of each triangle matches, then they are scaled copies. So which one would that be? That's problem 8. Problem number 9. Well, in other words, let me just see, that's A, let's say B. So for example, if this angle and this angle corresponds, and the second angles correspond, and the third angles of triangles correspond and congruent, if they are congruent, then they are scaled copies. So angle 1 to angle 1, angle 1 in A and angle 1 to B, to the triangle B, and angle 2 on triangle A and angle 2 on triangle A. So if they are congruent, if those 3 angles of each triangle are congruent, then they are scaled copies. Problem number 9. Elisa has 2 triangles. One triangle has side lengths 3 by 3 centimeter, 5 centimeter, and 7 centimeter. The other triangle has side lengths of 40 centimeter, 24 centimeter, and 50 centimeter. Are the 2 triangles scaled copies of each other? If so, what scale factor transforms the first triangle into the second triangle. So again, you gotta compare the small to small, medium to medium, and large to large, not first to first, second to second, and third to third. So be careful with that. And that's lesson 404.